Beer changes its flavor with time. And the question is that a good thing or a bad thing? A number of years ago at the University of California, Davis, a study was made of the messages that people received from the label. What I mean by that is people were given beers, imported beers, and domestic beers, beers from the United States, and they were asked to comment on their preference. When those beers were identified, in other words, the labels were shown to the people, there was a substantial preference for imported beers. People were saying, this is a great German beer, or a great Belgian beer, a great English beer, or a great Dutch beer, and so on. And the beers were preferred to the domestic beers, even though the imported beers, by the criteria that were applied by brewing scientists, those beers were stale. Those beers had flavor defects. When the beers were presented unlabeled, blind as it were, there was no preference, and nobody could actually come up with a preference for one beer style over another. That in itself begs questions, but the fact is that people are influenced by the label. Previously we talked about a significant imported beer market for the United States. A lot of beer coming into the United States. A lot of it is stale. Now the question is that a bad thing? Does it matter? Or is it something that we don't want? I recall somebody saying, I love Czech beer. And they've had the Czech beer in California. And they say, I'm really looking forward to going to the Czech Republic to taste it there. And they're going to have a shock. It's not going to taste the same. So is it okay to have stale beer? Is it a problem? It's a very difficult philosophical or semantic issue. The fact is that the flavor of beer changes with time. And one of the most significant changes is the decrease in the bitterness. The bitterness goes down. And you can actually measure the decrease in those iso-alpha acids from the hops going down in the beer with time. The beer increases in its harsh character. There is a decrease in what we call fruity or floral or estery character. There's an increase in ribes. Some people politely call that black currant buds. Other people less politely call it tomcat urine. The flavor that most brewing scientists talk about is an increase in the wet paper or cardboard character. So you get a distinct papery cardboard character, for example, on imported beer. Breadiness increases. The sweetness, like a toffee or a honey-like character, increases. The beer tastes more metallic. It gets more earthy. It increases in straw-like character. It gets more woody, more wine-like or sherry-like. And other changes can take place. We've talked a lot about hop aroma. Those hop materials that give the beautiful hop aroma, they can stick onto the package. For example, onto the crown cork at the top of the bottle. That's called scalping. So the hop aroma goes down with time. So many flavor changes can occur in beer. And the question is, do we need to worry about them? And if we do, how do we stop them from happening? Let me tell you a story about being a quality assurance manager with the Bass Brewing Company in the UK. And the biggest selling brand of beer in the UK, Carling Black Label. And back in the day, we made it in various breweries in the Bass organization, including the one where I was the quality assurance manager. And every month, every brewery that made this beer sent it into Burton-on-Trent, the mothership, and it was tasted. And every month, people said, which one is the Preston Brook beer? Everybody could identify it because it had a grainy character. Now, I'm not talking about flavor stability now. I'm talking about the flavor in the fresh beer. It was grainy. And we were told that we had to sort it out. So we did sort it out. The brewmaster and myself got rid of it. And headquarters were delighted. But the customers started sending the beer back to the brewery. What have you done to the beer? They got used to this grainy character and we'd taken it away. So we considered it a defect. The customer was looking for it. So there are many people in the world who are looking for the characteristics, stale characteristics, that brewers hate. So you've got to satisfy them. So you've got to decide, how do you get fresh beer, or how do you consistently get stale beer? It's a real challenge. And it's a particular challenge when you've got beer in things like green glass bottles. There's a famous beer that's imported into the United States in green glass bottles. If it's not seen any light, that's great. If it has seen light, it's going to go skunky. And depending on how old it is, it's also going to develop a stale character. So how do you control the flavor, and how do you make sure that the customer is getting the beer that has the flavor you would like them to receive, but also the flavor that they expect to receive? Now, there are some beers that improve in flavor with time. And we've talked about this in the context of barley wines before. Bigfoot barley wine, for example, from Sierra Nevada. You can do a vertical tasting of Bigfoot barley wine. You can go to the pub in Chico or into Mills River and taste how this year's compares with last year's and the year before. And you get some interesting development in flavors, probably because these products are up near to the wines in terms of their alcohol content. So not all beers decrease in quality with time. Some can change in different ways. And indeed, there's a history for beer being deliberately aged. Back in the day in England, for example, there was a thing called old ale. And beer was aged in the brewery in wooden barrels. And then this old ale was blended with younger, newly brewed beer to arrive at different products and different concepts, different styles, and beers with different flavors. So deliberate aging of beer is actually of historic significance. So there are numerous substances in beer, chemical materials, derived from the malt, hops, the yeast, the water, and so on, which influence the flavor of beer. And if any of them changes in its level, either an increase or a decrease, such that you can detect that difference by your senses, that's flavor instability. And some of these things are present at pretty low levels, tiny changes, and you can detect them, and that's flavor instability. So there may be 1,000 different things to worry about. So how do you do that? You can't pick them off one by one and say, I'm going to sort that out, and now I'm going to sort that out. So what the brewer has to have are generic solutions that are going to minimize all of the flavor change. And there are 3 of these. And the first is keeping the oxygen level in the finished beer as low as possible. Now, packaging technology over the years has got better and better and better. So you can get lower and lower oxygen levels in the beer. Even at the very low oxygen levels that brewers are capable of achieving now, there is still going to be the risk of flavor instability. But the lower the oxygen, the better. Now, when it comes to a bottle, air can get into that bottle with time. And how it does it is it squeezes in between the neck of the bottle and the crown cork. So it may seem like a tight seal, but air can get in. So oxygen is getting into that beer over time and making the beer go stale. The worst thing of all is to have a twist-off crown cork. If it's so loose that you can just twist it off, then there's a much bigger gap than if you have one of these pry-off crown corks. So the tighter the seal, the better. And indeed, it's possible for brewers to buy the crown corks which have got material on the inside of them which will trap oxygen. Oh, by the way, cans, best of all, because no oxygen, no air can creep into a can. No light can get into a can either. So although when you package into a can or you package beer into a bottle, with a bottle you can actually get to slightly lower oxygen levels. In a can, That's the end of it. There's no more air, no more oxygen going to get into a can. So for flavor stability and light resistance, the can is the best option. The second possibility is the use of what people variously call sulfur dioxide or metabisulfite. This is a material which prevents beer from staling so rapidly. Not absolute, but it slows things down. Now, in the United States, if you have more than 10 milligrams per litre of this material in a beverage, you have to label it. So on the can or the bottle label, it will say contains sulfites. I don't think you'll find any beer in the United States that's got the words contains sulfites on the label. And you're probably not going to find any wine that doesn't. The third important factor is temperature. The higher the temperature, the more rapidly will beer stale. So I'm standing here, room temperature. Now, room temperature is going to differ at different times of year in different places, but the classic room temperature is 20 degrees Celsius, so that's 68 degrees Fahrenheit. And as a rule of thumb, a beer will show or turn to an unacceptable degree of age character at that temperature in 100 days. So you got basically just around 3 and a bit months if you store a beer at room temperature. It'll depend on the beer. It's a guideline. If you increase that temperature by 10 degrees Celsius, the beer will stale 3 times faster. So if you're at 30 degrees Celsius, which is 86 degrees Fahrenheit, your beer is going to go stale in about a month. If you go to 40 degrees Celsius, which is about 104 degrees Fahrenheit, which it most definitely is in my garage in Davis, California in the summer months, then your beer is going to go stale in 10, 11 days. And if you go to 50 degrees Celsius, 122 degrees Fahrenheit, which you can get in parts of the world, then 3 or 4 days is how long it's going to last. And if you're at 60 degrees Celsius, drink it fast, because it's stale in a day. Don't think you'll encounter 60 in too many places, 140 Fahrenheit, but you'll get the message, I hope, that the warmer the beer, the more rapidly it will age. Now, if you take the beer down to 10 degrees Celsius or 50 degrees Fahrenheit, then 300 days is a rule of thumb. So if you're in the refrigerator, then the beer can last a lot longer. So the simple rule is store the beer cold. It's a simple rule. And there are several simple rules. Regarding the brewer, the first thing to do is to basically brew the beer as close to the customer as possible. This is one of the key reasons why Ken Grossman built a brewery in North Carolina, to serve the eastern half of the country. He actually takes other precautions as well, which we'll come to momentarily. And that is why it makes a lot of sense for some brewers to brew the beer under franchise and have it brewed by other people. People say to me, oh, that's not right. It's not authentic if it's not brewed where it originated. Let me give you an example. Bass. I'm a great devotee of Bass Ale. Let me tell you, Bass Ale, by the time, back in the day, having been brewed in Burton-on-Trent, by the time it got to America, it was mightily stale. These days, because the Bass brand is owned by Anheuser-Busch InBev, Bass is actually brewed in Baldwinsville, New York. And it's going to be a lot fresher. And people say, well, it can't be Bass. Of course it can be Bass. Because if you adjust the water to match that in Burton-on-Trent, which you can do, and if you use the correct malt and the correct hops and the correct yeast and the correct process, then you can recreate that beer irrespective of where it's brewed. There's a famous Japanese brand that for America is brewed in California. It's far better than shipping it across an ocean. So basically, find ways of brewing closer to the customer. That's a really key thing. Second thing is stock rotation. I've been in lots of places where they load the shelves with beer, and you order the beer and they pull it off the front, and there's still some left at the back, and they bring in the new supply and they put it in the front, leaving the stuff at the back. So rotating the stock, drinking the older stuff first, okay? Not letting it get too old, but turning it over. Critical. Something you should be looking for on beer bottles is a best before date or a packaging date. One company calls it a born on date, and that's when the beer was packaged. And some beers give you companies give you a clue to how long they recommend it should be, 100 days, 110 days, something like that. You should look for that. See how old that beer is. The younger the beer, for most beers, the better. Now, refrigerated storage, I've talked about, but also refrigerated distribution. That's what Sierra Nevada do. They ship their beer wherever it goes, anywhere on the planet, they ship it cold. And that is a commitment to fresh beer. The lowest possible oxygen content, so the best possible packaging facilities are so important if you really believe in achieving freshness in your beer. Cans and bottles. I've talked earlier about the psychological influence of the type of package. But when it comes to freshness, the can wins every time. And with the bottle, pry off is much better than twist off. Just a little bit of metabisulfite so you don't go over the labeling level. That's good. And if you're buying beer, don't take advantage of cheap offers. Don't go to the hypermarket or the supermarket who will sell you a pallet load of beer at a low price, because by the time you're ready to drink it all, a great deal of it is going to be stale unless you have a mighty walk-in refrigerator. So buy what you need for your own needs, your family needs, your friends' needs. No bargain hunting. Choose, buy beer wisely, and hope that the brewer you're buying it from is committed to freshness in their product. So you've heard me talk about the science of it all. Let's talk to Ryan Mintzer about the things that Sierra Nevada do to ensure low oxygen in the beer and storing and distributing that beer to ensure that the customer gets the freshest beer possible. So I'm with Ryan Mintzer, and I want to talk to him about his role with Sierra Nevada Brewing Company. Ryan.
Hi, Charlie.
What's your job title?
I am the packaging and warehouse manager here at Mills River.
So what does that mean? What do you do?
Well, at a high level, take the beer out of the brewing tanks, put them into bottles, cans, and kegs, deliver them to the warehouse, and load them on trucks so they can get to our customers.
Right. So, but not on your own. I mean, you're the manager. So.
Yeah, we've got a really great team. We've got 54 folks that work in packaging in the warehouse, and they're the ones responsible doing the work for operating the equipment and driving the forklifts and loading the trucks, receiving the raw materials, ensuring our quality is as best as we can possibly make it.
So is that 7 days a week?
We run 24 hours a day, about 5 days a week.
Right. Talk me through how the beer goes from the last stage in the brewery itself into right the way through to the warehouse. Just talk us through.
Yeah, sure. So it starts by receiving trucks that have glass bottles on them from the glass manufacturer. And they come on the form of a pallet. It's about 10 feet tall, and it's just stacked with bottles, bulk glass bottles of pallets. Those pallets are, when we're running the line, are delivered to our depalletizer. Our depalletizer sweeps layers of glass onto a conveyor, which is then fed to our filler in single file. It's brought onto the rinser first, and the rinser is a machine that actually uses sterilized water to rinse out the inside of the bottle. So it's basically cleaning any kind of dust or debris that may be left in the bottles from the previous manufacturing process.
So these are new bottles every time?
Yes. So we buy new bottles. We don't use renewed or recycled, reused glass, but we do a lot of recycling. So any glass that is not used or not sold, makes sure that it finds its way back to the glass plant so it can be melted down and put back into glass again.
Okay. So it's been washed. Now what?
So after it gets rinsed, it enters the filler through a series of star wheels. It enters the filler. We have 132 different valves on the filler. It's quite large. So each filler valve has one bottle, and inside the filler is beer, and it's basically shaped like a hollow donut. And on the bottom half of that donut is the liquid, and on the top half of that donut is CO2. So the beer
carbon dioxide.
Carbon dioxide, right. So the beer is kept under pressure, which helps reduce any foaming and makes filling a lot easier. And the other benefit is it's used to help remove oxygen, which is one of the key things when you're filling beer bottles, to ensure that you have as little oxygen as possible inside the bottle. And that really serves to ensure that the shelf life and the taste remains as fresh as possible.
So how do you control how much beer gets into each?
Sure. So the process starts with the empty bottle going on the filler. We have a vacuum pump which sucks the air out, and it uses carbon dioxide to flush the bottle so that it basically removes all the air, any residual air that would be in that bottle. Once the empty bottle is pressurized with CO2, the beer starts to flow in. And the beer will flow into, we have a vent tube, which is basically a hollow needle, which is maybe a centimeter in diameter. And the beer will flow through the outside of the bottle into the bottle. And as it rises the level, it rises up until it hits a needle, which we call a vent tube. So once it reaches that vent tube is when it stops filling. And that vent tube really is set to the right level of beer in the bottle. So it's set volumetrically for the inside of the bottle.
So all the time it's spinning around?
Right.
Yeah.
So we run that filler at 800 bottles a minute. It's very fast. Right. It's over 50,000 bottles an hour. And as the beer is flowing into the bottle, new beer is continuously flowing in a pipe from the brewing tanks into the bottom of the filler.
Right. Mm-hmm. So it goes all the way around, and then what?
So after it's done filling, it'll leave the filler and it'll go into the crowner. But before it gets to the crowner, it goes through a process called jetting, which is where we use hot water at high pressure. And it's a very fine stream of water that hits the surface of the beer inside the bottle and causes it to foam. Right. And what that does, it actually pushes out any residual air or oxygen that's inside that headspace on the neck of the bottle. And as soon as that foam starts to reach the surface of coming out of the bottle, it goes into our crowner and a crown's applied.
So you've got the crown on. It's just a glass bottle with a crown on it. There's no labeling?
Not yet. So after it leaves the crowner, there's a little bit of beer residue on the outside of the bottle, so it goes through what we call a doghouse, where it's rinsed with fresh, clean water. A doghouse.
Of course.
It looks like a miniature doghouse. Okay. And from there, it travels through a series of conveyors. We actually have an accumulation conveyor between the filler and labeler, which allows the labeler to have some stops without stopping the filler right away. So it's a little bit of a buffer. So the bottles travel through those conveyors and then they reach the labeler. Again, they're put into single file before they go onto the labeler.
So the label's got to go on there, at least one label.
That's right. And we have 3 labels. We have a neck label, a front label, and a back label. Right. And a lot of that is compliance. We need to state the type of beer it is and certain the alcohol content and things like that. But we also use it to reach out to our customers and describe what's in the bottle and what the style is, and maybe there's a cool story behind that product. So it's used in a lot of different ways.
So the label, I can remember from my days with the Bass Company in England, mm-hmm. Woe betide if you got the label on not quite true, square. Sure. It's got to be done properly.
That's right. Yeah, and labeling is it's a challenging machine to run because you think about the speed. The labeler, the base speed is 800 bottles per minute, but it also is part of a manufacturing line. The fillers are bottlenecks, so the labeler needs to be able to run faster than the filler so it can pull bottles away from it. So at times it's running up to 900 or even 1,000 bottles per minute, and you've got very small, thin pieces of paper which you're plucking off a magazine one at a time and arranging it and orienting it on the bottle. So it can be challenging at times.
And it's not only got to be the label at the front, the one at the back's got to be proper.
That's right.
And the one on the neck.
Yeah, so straight labels is very important for us, ensuring the neck label and the body label are aligned, and then ensuring the back labels equally spaced from the front label is important. And we have two packers, so we actually have a switch gate where you can determine, do you want to run it into 12 packs or do you want to run it into 6 packs? Or do you want to run it into both, which we can also do, so long as the can line's not running at the same time because they share a palletizer.
And so the actual packs are constructed, put into shape here as well?
That's correct. Yeah, we have what we call the dry side of the production bottle line, which is also known in the industry as kind of the box shop. So we receive cardboard onto flat stacks. Right. We put them onto a machine. We have a carton erector, which opens the actual shipping box of corrugate where the 6 packs will be placed. We have a basket erector, which opens up the 6 packs, and we have a basket inserter, which grabs 4 6-packs and sticks them into a box so that we can put the beer bottles inside of it.
So, I mean, is this done with robots or manually?
It's a highly automated process. Right. We run that area of the line with 3 operators. The operators primarily are loading the material into the machines, and then they're performing quality checks after the machine produces and opens the box and sticks the beer inside of it. We're checking that case to ensure it's got the proper integrity and it's going to withstand handling by the consumer and handling by the supply chain getting it to the consumer. So we're checking that our gluing is sufficient so that the box won't fail as somebody's holding it. And we're also checking to make sure that we've got the bottles look good. We're double checking the label orientation to make sure they're straight, and making sure it's as nice as we can get it for the consumer.
So now it's going to go onto a pallet or something like that?
Yeah, that's right. So once it leaves the packer, it leaves that single file. It goes through another inspection equipment. This time it's really looking for a missing bottle.
Right.
And that's really what it's looking for, which is a very rare phenomenon.
I've never seen it, but yeah.
But we double check. We don't want to sell anybody a case with 23 bottles in it. No. There needs to be 24 bottles in a case. But then it heads to our palletizer. And our palletizer, I think, is just fascinating. We have 2 of them. We typically run the bottle on one palletizer and the can line on the other. And the way this works is there's a case that feeds into the palletizer area, and there's a photo eye that detects that a case is present, and then there's a encoder which is on that conveyor, which is tracking how fast that case is moving, and that's relaying that signal to a robot, and that robot is actually grabbing that case and orienting it into the correct position so that it's forming a layer. And then once that layer is formed, that layer will drop down through an apron. It's basically a false door or trap door that will open, and it will lay that layer of cases onto the next layer below it. And that's how we form the pallet. Yeah, so once the pallets are formed, the pallets travel through another series of steps. So we put a top sheet on the pallet to ensure no dust or anything from a warehouse will get on top of the cases. And then it goes through a stretch wrapper. So the cases will actually get stretch wrapped with plastic. And that ensures that the cases and the pallet integrity won't fall over during shipment and transportation. So those are the real keys. And then once that pallet leaves that area, a smart pallet tag label will get applied to each pallet. And that gives us traceability, so we can determine when that pallet was produced and where it lives at any point in time during its life. Right. And it'll travel on a conveyor into the warehouse.
So, huge warehouse.
That's right.
How much beer can you hold in that warehouse?
We can hold over 400,000 cases of beer in the warehouse, which is quite a lot.
And it's fairly cool in that warehouse?
That's right. So we have 2 areas in the warehouse. We have cold storage, which is where our non-bottle conditioned beers go. Right. And they're always kept cold. So we keep that area at 42 degrees. It's basically a giant refrigerator. Right. About 150,000 square feet of refrigerated space. No. It's large. Yeah. We also have a smaller area for our bottle conditioned beer, and that's for a pale ale to be kept warm so that the yeast is still active. And
define warm.
62 degrees.
Fahrenheit.
Yeah. Correct, yeah.
So beer's been in the warehouse. Now it's going to be shipped. Are you responsible for the loading the trucks and that sort of thing?
I have not loaded a truck. I do not have my forklift license, but it's a really hard job, I'll tell you. Those guys move a lot of beer. We can load anywhere between 60 and 120 trucks a week, which is pretty significant. So there's a lot of beer heading out of here.
And those trucks are refrigerated?
That's right. That's another unique part about Sierra Nevada is, again, we don't have a pasteurizer, so it's very important the beer always stays cold. So we use freight lines that have refrigerated trucks. So our refrigerated trucks are also keeping the beer cold, and we actually ask our distributors to keep the beer cold in their warehouse. And in some cases, distributors have needed to build cold storage in order to house our product there.
And one of the main reasons is it slows down aging, so the beer stays fresh a lot longer by keeping it cold.
Yes, that's exactly right.